All right, so we're in 5.1 part 3 for business calculus. And sometimes an integrand needs to be multiplied out or otherwise rewritten before it can be integrated. So in order to make the integrating easier, always simplify first. I can't stress that enough. If you will take the time to simplify that thing first, integration will be 100 times easier. So looking at the next slide, I have two things that need to be integrated. The first one is the integral of x squared times the quantity x plus 6 squared dx. So what you want to do is simplify this out first. And what we're going to do is simplify the x plus 6 squared out. So that gives me x squared times, if you square x plus 6, you end up with x squared plus 12x plus 36 dx. And then you want to take one more step to distribute your x squared in, giving us the integral of x to the 4th plus 12x cubed plus 36x squared dx. Okay, I want you to pause the video now and simplify this, or not simplify, integrate this, and then come back and check your work. Okay, so after integrating, you should end up with 1/5 x to the 5th plus 3x to the 4th plus 12x cubed plus c. Okay? All right, so let's look at part B. In part B, I have the integral of 6t squared minus t all over t dt. And what we want to do here is I want to simplify this fraction. And the way we're going to do that is I'm going to divide each term on the top by t in the denominator. So when we do that, we end up with the integral of 6t squared over t minus t over t dt, which gives us the integral of 6t minus 1 dt. Okay? And when we take the integral here, we end up with 6 over 2t squared minus 1t plus c. We simplify that, we have 3t squared minus t plus c. Again, the first step, that very first step at the top, the part B, and even in part A, looks very daunting to take the integral. But once we do a few simple algebraic simplifications, by taking the time to simplify that, it's a much easier process and the integration goes very, very quickly. All right, let's try an example, like an application. All right, so a company's marginal cost function is MC of x equals 6 times the square root of x. And the fixed cost is $1,000. We need to find the cost function. So remember, we know that the derivative, I need my pen back. The derivative of cost gives us the marginal cost. Okay, so the inverse or the opposite operation tells us that the integral of the marginal cost dx is going to give us the cost function. Okay, those are inverse. So if we take the integral of this marginal cost function, so that's 6 times the square root of x, and I'm going to go ahead and write that as 6x to the 1/2. Since there's just one term, you don't necessarily need a parenthesis. So 6x to the 1/2 dx. Knowing I need to find the cost function, I'm going to take that integral. If you do 1/2 plus 1 is 3/2. So I know this is 6 times 2/3 x to the 3/2, and then plus c. Simplifying this out, we end up with 4 x to the 3/2 plus c. But that's not a very useful cost function to have an arbitrary constant in there. Well, they've given you that C value, the fixed cost when X is equal to 0. Okay, no matter what they have to pay is $1,000. That fixed cost, 9 times out of 10, ends up being the C. Okay? Because fixed cost are C of 0. So in this case, it's $1,000. Okay, so if I did 4 times 0 to the 3/2 plus C equal to 1,000, this cancels out, and I get C equal to 1,000. So my cost function, that C of X that I need, is 4x to the 3/2 plus 1,000. And you're done. You've gone from the marginal cost function that you were given, worked your way backwards through integration to get the cost function. All right. Let's keep going. So we found that the cost function in 2 steps. We integrate the marginal cost. Okay, so there's step 1, integrate the marginal cost, and then evaluating the arbitrary constant. Other problems that involve recovering a quantity from its marginal or rate of change together with a particular value are solved in the exact same way. Okay, so if we want to recover a function from the marginal or rate of change function, it's the same steps every time. Okay? The integration, we integrate the marginal or the rate of change, and then that fixed value is use that fixed value to evaluate the arbitrary constant. Okay, so let's try one more. The gross domestic product, GDP, of a country is $78 billion and growing at a rate of 4.4 t to the negative 1/3 billion dollars per year after t years. We need to find the formula for the GDP after t years and then use our formula to find the GDP after 8 years. Okay? So the hint here in the wording that we know we have a rate of change, or we have a marginal. Okay, for this one it's a rate of change. We see the phrase growing at a rate per year. Okay, so this is our rate of change formula. Okay, and that's the wording that you're looking for. Growing at a rate of blah, blah, blah per year. Okay, or per month or per week or whatever. So I need to integrate 4.4 t to the negative 1/3 dt. Okay? So here we're going to have 4.4, and I totally forgot my 1. Sorry, negative 1/3. 4.4 times, if we do negative 1/3 plus 1, we get 2/3. So remember, it's 1 over 2/3 or 3/2 t to the 2/3 plus c. Right? If you multiply 4.4 times 3 over 2, we end up with 6.6 t to the 2/3 plus c. Now remember, we can't just leave the arbitrary constant there. We've got to go back and solve it. Well, at time 0, what we were given is, at time 0 that we know, is the gross domestic product is $78 billion. Okay? So if you plugged 0 in for t, we just have the c left, that gives our GDP formula. And in the book, if you're looking, they call that G of t. you do whatever you needed to. That GDP formula is 6.6 t to the 2/3 plus 78. And this gives us, sorry, there it goes. This right here gives us the GDP after t years. We can then go further to evaluate or at 8 years. Okay, so we want to find G of 8, so 6.6 times 8 to the 2/3 plus 78. If you plug all that in, we end up with 104.4. So that means after 8 years, the GDP after 8 years is $104.4 billion. Okay. All right, so I'm going to stop this video here, and we're going to talk more about the geometric interpretation of integrals in the next video.